Okay, this is the last part of section 5.7. I'm going to go through two problems on how to integrate by completing the square. So these are the two typical problems that you'll see. So when you see these problems, you're going to think in your head, okay, do any of the other integration techniques work? Well, neither of them factor. I don't want to do long division because you want the degree to be the same or bigger on the top. And it's not going to be a 1 over u because I'm missing a du. So when you have a quadratic on the bottom that does not factor and it doesn't fit one of the other rules, that's how you know you're going to complete the square. So we want to figure out a way to rewrite the problem so I can integrate it, because I cannot integrate it the way it's set up. So completing the square, if you remember from pre-calc, what you're going to do is you're going to be adding a number so in order that this can be factored. So the way you figure out what number to add is half of this number is 2, 2 squared is 4. So I'm going to add a 4. But you can't just add a 4, you've rewritten the original problem then. So that plus 7 is still there, but in order to keep this expression balanced, if I'm going to add a 4, I should also subtract the 4. So really, this is the same expression, right? Plus 4 minus 4 is the same thing. But what this allows us to do is this factors into x minus 2 squared. This gives me 3. So now I can rewrite this problem in this form. And now when I see this, this is my arctangent right here. Your a is your square root of 3. Your u is x minus 2. My du is dx. So I'm not really missing anything. So this fits my arctangent rule so your antiderivative is going to be 1 over a arctangent of u over a plus c. Remember, even though I have this written first, your u should always be the piece that has the x, your a is always the piece that has the number. Okay, number 2, same idea. We're going to have to rewrite this somehow. I'm going to go ahead and complete the square. So I'm always adding something. So half of 6 is 3. 3 squared is 9. This plus 10 is still there, but I need to subtract 9 to balance it. So this factors to x plus 3 squared. This gives me plus 1. Now I can rewrite this problem to x plus 3 squared plus 1. And again, this fits my arctangent. My a is 1 squared. My u is x plus 3. My du is dx again. I'm not missing anything for my du, so this is my arctangent. Arctangent is 1 over a, which is just 1. Arctangent of u over a, which is 1 plus c.